told you that L'Hopital's rule is not the answer to this limit problem here. You can use it, but there's actually a faster and better method, but only if you stick around will you understand what it is. So the issue with L'Hopital's rule with this problem is if you're using a blind trick like that without understanding what it is you're working with, you're going to waste valuable time on your AP exam, and it's just going to complicate this problem. So yes, even if you can use it and get the right answer, I want you to understand the problem you're working with and step back and first look at it to see if there's a faster method. What do you notice we have here in common between sine of 2x and 2 sine x cosine of x? Think about it for a minute and think about your trig identities. Okay, in case you don't remember it, sine of 2x is in fact 2 sine of x cosine of x. So I can actually rewrite the numerator as the following. So now we have 2 sine of x cosine of x appearing in two different spots here in the numerator. And then when we subtract the terms, this is going to give us a simpler limit to work with. That's going to be 2 sine x cosine of x on the numerator. And we still have this x term on the denominator. And maybe here is where you get stuck and why you jump to tools like L'Hopital's rule. Because of L'Hopital's rule, sometimes it helps us to not have to think about what to do next. But I want you to get a little creative here and remember an important thing about limits. First of all, you don't have to do it for this problem, but I'm going to go ahead and just pull this constant 2 out in front because I think it'll make it easier for me personally, and your preference might be different. And then the next thing you can do is something really cool here. And before I mention it, if you're finding value in my videos, you need to kick that subscribe button and turn on that bell notification so you don't miss my videos in the future. And if you want to watch them early, you can actually become a member for just $1 a month, and you get some really cool additional goodies. And you can find that all out in the description below. So remember, the other thing we can do here with limits is if you have a product of terms on the numerator here, we can split this limit into two parts where you have a product of limits. So I'm going to go ahead and do that here. And the reason why I'm going to do that is for the following. This might not look like an easier problem to you because we have this sine of x over x expression, but this is one that you have to remember for your exams. This is a very famous squeeze limit theorem. And if you're approaching 0 for x, the limit for sine of x over x approaches the value 1, which is a constant. And this is one where you want to be careful about using L'Hopital's rule on this. I have a video about all the pitfalls above. And if you remember, for very small values of x, sine of x approximates a value of x, right? And that's where that comes from, the squeeze limit. Now for the right term here, check this out. Isn't that easy? The limit as x approaches 0 of cosine of x, by inspection, you can tell that we can safely plug in a 0 there because we're not having to worry about dividing by 0. So now that we know that the squeeze limit theorem here tells us that this limit approaches 1, and the one on the right is just cosine of 0, when you simplify this, you get a final answer of 2.